Alright guys, hey, I'm back. My name's Shivankar, like I said, and we'll be continuing with the previous video talking about thermodynamics, which is topic 10 in our physics, IB physics, which we're trying to help you guys get through. So next I'll be looking at the 10.2.6 part of the syllabus, which involves calculating from a PV diagram, which you can clearly see I've drawn over here, a nice looking PV diagram with everything labeled and everything. We're going to calculate the work done. And as Eddie briefly stated in his previous videos, work in a PV diagram is the area under the curve, or in this case, the total area that's occupied by this shape of this by this entire cycle. And this cycle is referred to as an ABCD cycle. C-D a cycle. So in one cycle of this entire process, what is the overall work output? Now, the thermodynamic definition of work, pay attention to the right corner over here. The thermodynamic definition of work is, let's use a different color, is work is equal to the integral of pressure as it varies with volume, or the integral of pressure with respect to volume. In other words, the area under the curve. In over here, let's try and calculate the area or the work done in this process. So we know that as I said in my previous video, AB we know is an isochoric process where the volume stays the same, so we can be sure that there's no work done during this process. Same for CD. However, in BC there's an isothermal process going on, and so is there in DA. However, the work done in DA is negative while the work done in BC is positive. Now why? Why? Because in BC, as you can see, we're undergoing an expansion from a volume of 0.2 meter cube to a volume of 0.5 meter cube. Just try and visualize this in the piston diagram that we had in the earlier videos. And so once you expand the volume, it's the gas that's actually doing work to move that piston a certain distance, and so work's done out, and which is why it's greater than 0. This also fits in. This also makes sense. It's intuitive because of our delta U is equal to Q minus work. Because if the work done is positive, then there will be a decrease in internal energy, and this makes sense because if the particles have done work to move the piston a certain distance, they will have lost energy. Now, back to calculating the work done during this process. As I said, work is the integral of PdV. This is not really going to, you won't really need to state this during your physics exams and stuff, but just keep this in mind that this is the actual definition. So, in this case, like I said, since there's no work done during A, B, and CD, the work during A, B, C, D, A. Let me just rewrite that. So once again, the work done during one cycle, or the work total, is equal to work done during BC C plus the work done during dA. Right? Now, since we know that the work done during dA is negative and the work done during BC is positive, what we can do is we can basically create a parallelogram to approximate the area. And this creates a parallelogram under it, and which has the area formula of base times height. I'll just draw the parallelogram more clearly so you can see what I mean. Let's use, what color you guys want? Red? Yeah, let's just keep going with red. So right here, this would be the straight line the parallelogram forms. As opposed to the curve. Same thing here. Instead of the isothermal curve, it would be a straight line. It's not too straight, but I'll try my best. Okay, seems good enough. And so we know that the area of a parallelogram is equal to base times height. Now in this case, it's pretty clear the height's given to us. The height in this case is going to be pressure, and that change in pressure is equivalent for AB and CD, and the height is equal to, can you tell me? Yes, you're right, it's equal to 2 times 10 to the 5th pascals. Okay, and the base, in contrast, would be the change in volume, and in this case the horizontal change in volume is clearly 0.3, which would be illustrated by this. So let's go back to yellow. Over there. So the base, oops, gotta change color. So the base is equal to 0.3 meters cubed. Hence, the area, which is equal to the work done, is equal to 0.3 times 2 times 10 to the 5th, which ultimately equals 6 times 10 to the 4th, oops, 10 to the 4th joules, or 60 kilojoules. That is a lot of power. Yep, that's it for this one. Thank you guys, and see you in the next video.